Okay, so what I'm going to do in this video is go through how you get the force of an object down an inclined plane or a slope. So we're starting off here with a box, simple box on a slope. You'll always be given the angle of the slope, and gravity is going to pull on that box straight down. So the force that we have written in here is force of gravity, the mass times acceleration due to gravity, g. That, because it's a vector, can be split into two components. One component drawn here is perpendicular to the slope, and the other component drawn here is parallel to the slope. Now, what this component is doing is it's pulling the box down and keeping it on the slope. This component over here is causing it to move or to accelerate down the slope. Now, generally, this is the component that you're going to have to find out in a question. So, how do we go about doing this? Well, let's start over here with putting the angle for the slope that you're given here. Where does that fit into this? So actually, and again, I'm not going to go through the ins and outs of why this is the case, but this is always your angle of the slope here. So between the perpendicular and mg. Now, what makes this much easier is if you take this diagram and if you flip it over. So what I'm going to do is I'm going to flip it. I'm going to basically take all of this and I'm going to rotate this around. So we have our two vectors. Now I have my mg. And then I'm going to put my angle of 10 degrees in here. Now let's give these labels. So we'll call this F1 and we'll call this F2. So where is this then is F2 and this here is F1. So take a moment just to picture that in your head. I'm taking all of this and I'm just rotating it around so that it looks a bit more familiar. Now, if you were given a question here, what you're really asked to do is find out, well, what is F1? And we know that the component that has the angle in it is always the cos component. So F2 is going to be mg cos of 10 degrees. Okay? And F1 is going to be mg sine of 10 degrees. So that means that this component here is whatever mg is times sine of the angle of the incline. And in this case, it's 10 degrees. Getting a bit squashed there, but you can see what's happening. Now, you can learn that off, or what I think is much better is to be able to reason it. Draw your diagram, put the angle in, rotate it, and it makes a lot more sense that way.